In another lecture, we talk about how to solve right triangles. In this, we're going to talk about how to solve other type of triangles, what we call the oblique triangles. So oblique triangle is a triangle without a right triangle. So we call oblique triangles, which doesn't have a right triangle. But when you have these kind of oblique triangles, you need the rule what we call the laws of sines. Laws of sines. There are two type of oblique triangles. So one is a acute triangle, that means all the angles are acute angles, and the other one is a obtuse triangle, that means there's one angle which is more than 90 degree, or which is an obtuse angle. So these are the two types we're going to solve right now. And then you can see that you cannot use the standard right triangle methods to solve these triangles, because we do not have right triangles here. So there are five possible cases. There are five possible cases. So the first one is what we call the ASA. ASA, that means we know an angle, a side, and an angle. And the next one is what we call SAA, that means we know a side and two angles. And then the next one is SSA, that means we know two sides and then an angle, in this order. So what is important here is you need to have a SA pair. What is SA pair means? You need to have a side and an opposite angle. If you know side and the opposite angle, we can use the sine laws. So, and then you can see that in this case we have a side and opposite angle pair. We know the side and the opposite angle. In the third case also we know that the sine and opposite angle, but in the first one you do not know a side and opposite angle. But what you can do is, since you know two angles, you can actually find this angle using, because we know the sum of the three angles is 180. We can use that, and then we can find that angle first. So after that we can use the side angle property. So side angle pair. So that is the most important one. So when you have a side angle pair, we can use the sine laws. So we can write it. So that means, so what happened here is, so in these three cases, that's why these three cases are important. So what we know, so no one, is side angle pair. No one, no one side angle pair. So that's the most important. So if you know the side angle pair, what we can use, we can use the laws of sine. So we use the laws of sine. Use the laws of sine. Laws of sine. And then let's do the other two cases. So the next one is what we call the SAS case. So in this case, what we know a side, an angle, and another side. But in this case, you can see that there's no way you can come up with a side angle pair, because you don't know two angles. So that means if you don't know two angles, you cannot directly find what is the other angle is. So that means there's a difficulty here. So you cannot use the sine law in this case. And also the last one is, we know like three sides. So that's what we call SSS case. So we know the all three sides, but you can see that we don't know any of those angles. So in this case, what we can do, we can use what we call so we don't have a side angle pair, or we cannot make a side angle pair. So what we can do, we can use the other one that we can discuss in another lecture. We can use the laws of cosine. So we can use the laws of cosine. So that's the difference between the two. So when you know side angle pair, or you can make a side angle pair, you can use the laws of sine. And when you cannot come up with a side angle pair, and we can use the laws of cosine. So let's discuss what is the sine law now. So let's recall that the laws of sine is used when there is a side angle pair. So there should be opposite angle to a side. So then we can use the side angle pair, and you can see that it will be very clear when we talk about the problems. And also there's something we try to find angles first if possible, and this will also be clear when we talk about problems. So let's see what is the what we mean by the sine laws of sine. So the laws of sine says that for any triangle with sides ABC and the opposite angles, the corresponding angles opposite to those sides are ABC respectively. So what it says that, so that means, so let's look at a triangle. So that means, so we have a triangle like this. It can be any triangle. So we have a triangle like that. So I'm going to call it A, B, and C. So those are the corresponding angles also. We use the standard naming convention that we discussed in the previous lecture. And then so the corresponding sides, so we're going to call this side is B, and then this side is C, and this side is A. So those are the opposite sides. So the you can see the A angle is opposite to the A side. So like that. Then what it says that, then it says A divided by sine of the angle. So it can be any angle. It can be right angle or even obtuse angle. So it doesn't really matter. So sine A equal B over sine B equal C over sine C. It's a very interesting result. So this is what we call the sine law. And then later we're gonna know that this is equals to 2 times R, like uppercase R. What is this R? And we know that when you have any triangle, there is a circle that passes through all these vertex. So what we normally call the circumcircle. So let's draw the circumcircle in this case. So that's a circumcircle, and then this circle has a radius. So you can mark the radius as a center. So that's the radius, and this radius is normally we call the uppercase R as a radius of the circumcircle. So that this quantity is actually equals to 2 times R. We can show that works, but we are going to show it. But that's where that's constant coming from, is 2 times R. So so this is what we call the sine law. So that means A divided by the sine of the corresponding angle, B divided by the sine of the corresponding angle, and C divided by the corresponding angle. All those three are equal to each other, and we call this is a sine law. And then we also have some other properties. So we also have the sum of the three angles, like A plus B plus C equal 180, because those are the three angles. This is another important result. And then also we know that like for any triangle, if you get the sum of the two smaller side, sum of the small side has to be larger than the largest side. So if you say A and B are small sides, so that means if A and B are small side, I'll just pick this one, and then it has to be bigger than the largest side. So these are the small side or the short side. If you say those are the short sides, then the sum of those short sides has to be bigger than the larger side. Okay, so those are the things that we're going to use, and let's see how we're going to use these in problems. So first we're going to solve a SAA triangle. That means we know one side and two angles. So in this case, and you can see that there is an SA pair. So let's look at this problem. So as a first example, we can say solve the triangle with A equal 42 degrees, B equal 57 degrees, and A equal 4. So we can use the standard naming convention. So we can draw a triangle to represent that. So we have 42 degrees and 57 degrees. And then, so this is the A vertex or the A angle. And opposite to that, we have A side. So it is A equal 4, which is given. So this is B, and this is the angle C, or the sides or the vertex C. We can use both C to represent either vertex or the angle. And then so this is the side B that we are looking for, and then this is the C that we are looking for. And then you can see that if you look at this situation, you can see there's a angle side pair. We know that both angle A and the side A. So let's see how we can solve this. So we can use that to solve the sine laws to find the other missing ones. So let's start with the finding angle first, because that's the easy one. So you can see, since A plus B plus C is 180, and then we can plug in. We know A is 42, and then B is 57 plus C equal 180. So that means C has to be 180 minus those two angles, 42 and 57. If you subtract, you end up getting 81. And then you can see that this is the exact value. So we try to use exact values as much as we can to avoid errors. Now what we can do, we can use the sine law to find the rest of the angles, rest of the sides. So we can see that since we know A pair, that's the side angle pair. So to find B, what we can do is we can use a sine law. So what we normally do, we can try to write, because these are all fractions, we can write the missing one as a numerator. That's easy to solve. So we can write B over sine B equal A over sine A, because that's the known one. We can write like that, and then we can plug in. So if you plug in, we're gonna get B over, we know the sine B, we know the angle B, which is sine 57, and then equal A is 4, so 4 over sine angle A is 42, and you can see that this directly give you the value of B, because by cross multiplying, you can write this one as 4 times sine 57 divided by sine 42. So now if you use a calculator, and you can get the value up to 2 decimal places, and you can see that this can say B equal 5.01 up to 2 decimal places. So that's how you use the sine law to find the unknown. And then again, to find C, we do the same thing. We can write C, because that's what we are looking for, over sine C, which is again equal to A over sine A. So what we do, from the sine law, we only use 2 at a time, because, and then we need to know 3 of them, and then we can find the missing one. That's how we do. And then again, from this one, it's also clear that it's a C over sine C, we already know, which is 81, which is equals to 4 over sine 42, and again as before, you can see that C equals to 4 times sine 81 over sine 42, again using a calculator up to 2 decimal places, and you're going to see that you're going to get 5.90 as the other side. So then we found all 3 angles, and then also because 2 angles were given, and we find the other angle, and also one side was given. To find the other 2 sides, we use the sine law. As the next one, we're going to solve a ASA triangle. What is ASA? We have a angle side angle, but when you have angle side angle, the problem is that there is no SA pair. You cannot find a side angle pair opposite to each other. So what we can do is, but we can make one, because since we know 2 angles, we can find the other angle using A plus B plus C equal 180 property, and then we're gonna get a side angle property, side angle pair. So let's see how, let's look at this problem now. So we have solved the triangle A equal 35, B equal 15, and C equal 7. So let's draw the corresponding situation. So let's put the information that we have. So I'm going to call it A and B and C. And then this side, so we have angle 35 here, and then also 15 there, and then we have side C, so C equals 7. And then so you can see that there is no side angle pair. So what we're gonna do, we can find this angle C using the sum angle property, and then after we do that, then we're gonna get the CC pair. They are opposite to each other, because otherwise you can see that so we don't have this side, or we also don't know that side. So that's the difficulty here. And then I'm going to call this side A and this side B. So so we can write it. We know that A plus B plus C equal 180. From that we can find the missing side. So then this is that C equal 180 minus A minus B. So if you plug in, which is 180 minus 35 minus 15, so this is going to give you 130. So that means angle C is 130. But once you find that angle, then we're going to get the CC pair. Now we can say, since we know the CC uppercase lowercase CC pair, we can use a sine law. So to find A, what we can do, we can write A over, we're going to plug in corresponding opposite angle is 35 to A, and then we can write the CC pair here, which is C is 7, and the corresponding, the opposite angle is 130, that we just found. And then this can give you the value of A, which is 7 times sine 35 over, by just cross multiply. You can cross multiply them. So I multiply by sine 35. So and then divided by sine 130. And if you use a calculator, this is exact value, but if you use a calculator, you can see that you're going to get 5.24 up to 2 decimal places. And also we can, to find B, we can write B top, and then corresponding angle, the opposite angle to B, side B is 15, and equal the same ratio, 7 over sine 130. And again, this can give you B equal 7 times sine 15, in this case, sine 15 divided by sine 130. So again, using a calculator, you can get the approximate value is 2.37. So that's how you can solve a problem even when you do not have a SA pair. But we can see that in the ASA case, you can make a SA pair. And once you do that, just finding the angle. Once you do that, then since we have a SA pair, we can use the sine law to find the other missing angles, other missing sides. Good. So let's look at the next case. So we solve ASA and SAA cases, and you can see that in those cases, either we found a SA pair or we can make a SA pair. But in this case, what happened, when you have SSA, we actually have a SA pair directly. But the problem is, depending on the other side, because we have two sides and one angle, depending on the other side, we can see that there are 4 possible cases in this situation, because sometimes even there are no triangles, and then there are sometimes 2 triangles, and there's only 1 triangle. So let's look at those 4 cases one by one and see how that can happen. So we have solved the triangle A equal 2, C equal 1, and C equal 50 degrees. So let's draw the situation. So we have A equal 2, and the angle is 50, which is opposite to C. So then C is given, which is 1. So what we're trying to do, let's try to find the angle A. So like we kind of blindly try to find this angle A. So we can say to find A, because we can see that we have a CC pair now. So that's the CC pair. so we can use that. So that means, so what we, since we are looking for the angle, I'm going to write that top. So sine A over A equal sine C over small c. And if you plug in, so what's going to happen? You can see sine A over small a equal 2, that's given. And then sine C, which is 50 over small c, which is equal to 1. And then now if you solve for sine A, so what do you get? Sine A equal 2 times sine 50, and if you use a calculator, and you're going to see that you're going to get 1.53, which is greater than 1. Now you can see that this is a problem because this is a sine value, and we know that the sine can never be greater than 1. So that means, which is impossible because there's no way you can solve for A. So this is impossible. So this is impossible. So what does that mean? So it's like you can say it's a contradiction. So what does that mean? There's no such triangle. So you can say that there is no such triangle. Okay, so that's a no triangle situation. So you're gonna get the length C is smaller than the expected length of the perpendicular. So that means there's no such triangle. So let's look at the next one. Solve the triangle A equal 5, C equal 13, and angle A equal 22.62. So if you draw the situation, so what we have is, so we have the C, which is 13, and then the angle A, which is given, which is 22.62, and then what else? So this is B, that we don't know, but A is given, so A is 5, so equal 5. So what we're trying to do, we try to find this. So you can see that you can find the angle now because we have a AA pair. We know the AA pair, and then we also know one side, that means we can find the corresponding angle C. So let's use the sine law now. So using sine law, so we're gonna get that sine C over small c equal sine A over small a, and then we can plug in here. So that means you can solve this. So we can say that sine C equals to small c over small a sine A, and then if you plug in, which is 13 over 5 sine 22.62. And if you use a calculator, and if you find this value and something interesting happen, and you can see that you're going to get a value which is 1.00000. It's like it's correct up to 5 decimal places, you're going to get 1. So what does that mean? So this means that and if you look at the graph of sine, if you look at the graph of sine, and you can see that there's only one value from 0 to 80, that's going to give you a 1. It's only one value. We have just one value, and which is 90. So that means this is that C exactly equal to 90 degrees. So since C is 90, then we can find the value B. You can by subtracting. So we can say, so B equal 180 minus A minus C, because those are two angles. So, and then we can subtract them, and you can see that you're going to get 180 minus A is 22.62, C is 90, and if you subtract them, you're going to get 67.38. So that's the angle B. So now we know all three angles, and we already know two sides. To find the other side, since this is a 90 degree, we can use a Pythagorean identity. You can also use the sine law, but I'm going to use a Pythagorean identity because this angle C is 90. So we can say since C equal 90 degree, by the Pythagorean identity, we have a squared plus a b squared equals c squared, and this can give you b squared equal 13 squared minus 5 squared, because we know 13 and 5 is thus given, and then this can give you 169 minus 25, which is 144. This is a complete square, so that means b has to be 12, because this is a positive value. So thus we find all the sides. So this a equal 5, b equal 12, c equal 13, and then a equal 22.62, and then b equal 67.38, and c which is 90. Okay, so that's, we normally write that line after you find those values. Okay, this is how we solve the problem. So, and then you can see that there's only one case. Okay, only one. So you can see that only one solution. Only one solution in this case. Okay, let's look at the next problem. Solve the triangle A equal 3, B equal 4, and angle A equal 35. So let's draw the situation. So what we're trying to do is, using the information, we're going to find the value of B. And let's see what's going to happen when you do that. So using the law of sines, so you can see using law of sines, and A pair. So we have a pair because we know the A angle and the A side. So we can say a pair. For B, we can write sine B over B equals sine A over A, and we can plug in. So that means says that sine B equals B over A sine A. So let's plug in. So this is going to be 4/3, because B equal 4 and A equal 3, sine A equal 35. And if you use a calculator, and you can see that this is going to be 0.7648. So that's like a good value, because sine can be between 0 and 1, because these are positive values. And then what we're going to do, so you can see that if you look at the graph, if you look at the sine graph again, so what's going to happen? So we are looking for values between 0 and 180, but the problem here is, if you have, because this is 1, so that's the one we are looking for. So you can see that there are two values between 0 and 180. There are two values. Sine give you two values. So those two values going to create two triangles. So you can see that there are two angles. There are two angles. So we can say B1, which is directly coming from the inverse, which is sine inverse 0.7648, and if it's a calculator, this is roughly 49.9. And to find the other value, what we can do is, it is 1 minus this angle. So, and then B2 you can calculate. So B2 equals it is 180 this angle 49.9. So that means it is going to be 130.1 degrees. Those are the two angles, two possible values for B1. Why this happened? Because we know that when you have a sine value which is equals to some value between 0 and 1, there are two values coming from the sine. And then what we can do now, according to corresponding these two angles, there are corresponding C angles. There are two triangles now. So that means you can see the other angle is C1, which is 180 minus A minus B. So if you plug in there, so it is 180 minus 35, that's A, minus the 49.9 value. So you're going to get, in this case, you're going to get 95.1. And then for the other one, so you can see 2, which is again 180 minus 35 minus 130.1, and you can see that you're going to get 14.9. Those are the two cases. So let's draw two triangles to those two cases. So we have these two cases, and you can see the first case is when the angle B is 49.9, and the second one is when the angle at B is 130.1. So those are the two different triangles. In the last one, I also draw the other one on over there. Then you can see how those two triangles gonna happen here. And then this is the vertex C. So what we're trying to do is we're gonna find these two values, C1 and C2, corresponding to these two cases. For that, we're gonna use a sine law. So to find sine, to find C, we can write C over the corresponding angle, which is sine 95.1, equal, and then we can use one of those pairs. So we can use the AA pair. So we can use this pair. So we can write 3 over sine 35, and then solving this, we can find C. So C is simply 3 times sine 95.1 divided by sine 35, and if you use a calculator, and you can see that the C1 value is simply 5.21, and similarly we can find the other one also. So if you write C2 over sine, in this case 14.9, equal, again the same pair, 3 over sine 35, and you can see that the C2 is 3 times sine 14.9 divided by sine 35. Again, if you use a calculator, you can see that you're going to get 1.34. So that's how you solve those triangles. Let's just do one example, one more practical problem. Remember, like in a previous lecture, we talked about how to find the height of a mountain, and we can do this problem using the new method, and you can see that this method is much quicker than what you did earlier. So let's do the mountain problem again. So we discussed this problem earlier. So how to find the height of a mountain, because that's a practical difficulty, because we cannot go to the inside of the mountain. So what we do, we have to get all the calculation outside of the mountain. So what we normally do, we're gonna go like a perpendicular to the mountain. Like we're gonna take one angle of elevation. So in this case, we're gonna get theta1, and then we're gonna go away from it, like let's say 500 meters, and then we take another angle of elevation, and then using those information, actually we can find the height of the mountain. So but last time we just used the right angle method, but here we can see, let's see how we can use the science law, because that's much quicker. So what we're gonna do, I'm gonna call this side is A, and then what we can do is we can actually find this because the goal is to find a side angle pair. So, and you can see that we don't have a side angle pair, but after you find this top angle, and you can see this angle is simply from the extended angle theorem, it should be 49 minus 32. The difference between those two angles is the angle over there. So which is you can see 17. So now what we can do, now you can see we have an side angle property, because we have the 17-degree angle and the 500 as the side, and from that we can find A first. Once you find A, then you use this triangle inside to find H. So I'm going to put some letters here. So I'm going to call this is A, and this is B, and then we have C, and then D. So let's say, so now what we can do using sine law, and the triangle A, B, and C gives, you can say is A over sine 32 equal 500 over sine 170. Now A, which is equals to 500 times sine 32 divided by sine 170. And then if you use a calculator, and you can see that this is roughly 906.24 meters. Now, so that means we know the length of A. Now what we can do, we can use the other triangle, which is a right triangle. From that we can find H. So now you can see by the BCD triangle, if you use that, you can see that sine 49, because we know the hypotenuse and we are looking for the opposite side, so we're going to go sine. So sine 49 equal H over A. In this case H we don't know, but A we know, so it is 906.24, and solving for H, you can see that H equal 906.24 times sine 49, and if you use a calculator you will end up getting 684.0 meters. So that's how you can use a sine law, and you can see that this is much quicker than how we did earlier, because that calculation was a little bit difficult. So this is the end of law of sine lecture. Let's have a short summary of what we did, and we use a side angle pair, and then also knowing three known values, and then what we're gonna do, we're gonna pick two of them. Like for example, we have three, we're gonna, let's say we pick these two. So and then what we need to know, we need to know three. So you knowing any three, we can find the other one. For example, let's say you know A, C and C, then you can find sine A, like that. So knowing three, we can find the other one. And then when you try to find the angle, the missing angle A or the sine, there are three cases. The first case is sine A. When you look at this, you can see that you can sine A maybe simplifies to something greater than 1. That means there are no solutions in this case because it's not real. And then we can also have sine A equal to exactly 1. In this case, there's only one solution. So there's a one solution. That means one triangle. And then the other one can be sine A less than 1. So that means in this case, there may be, because there are normally, because if you look at the graph and you know that sine graph going to cut at 2 points. So because of that, there are two solutions. So I'm going to say there may be two solutions. Sometimes what happens, one solution is not possible, because when you try to look at the sum up of the angle ABC, sometimes you get more than 180. In that case, one angle is not possible, but we still have at least one solution. So this is how we're going to use the sine law.